All right, let's take a look.
I tried. No, we didn't want one line, except you were started.
All right, on this one here, when you have a sine value and a cosine value, and what you want to do is you want to create a square. So you square both sides. So when you square both sides, so you have 1 minus 2 sine x plus sine squared. You get that. Now, since I have more sines than cosines, I'm going to rewrite cosine in terms of sine.
Yeah, all right. I got sine squared. I got to there.
Okay.
And then I was stuck.
So you have 1 minus 2 sine, I'm putting some descending order, that drives me nuts. Sine squared x minus 2 sine x plus 1 equals 3 times.
And then I didn't know if you had to
Distribute. And now you set your side equal to 0 by adding the 3 sine squared x and subtracting 3.
Now would you take out a 2?
Yeah. Yeah, take out a 2. Yeah, exactly. You can get rid of the 2. I'm going to rewrite it in terms of u real quick. So 2u squared minus u minus 1. So that's 2u minus. What times what's negative 2? You add together negative 1, so negative 2 plus u minus 1. That's u squared. So you have 2. This was sine of x minus 1 is 0, and sine of x minus 1 is 0. So what angle has a sine value of a half? And what angle has a sine value of 1? I'm sorry.
I watched the video for the first time, but then I didn't do the homework, so I didn't know how I go on.
Oh, it's okay. We've all been doing the same stuff in the past couple of days.
Oh, pi over 6.
All right. So now when you go through this one, you have what angle has a sine value of a half? That puts you at pi over 6 and 5 pi over 6. And where is the sine value equal to 1?
Sine is y. So,
Mr. Murphy, did you mess up somewhere in there? You have 2u and then a plus 1, and then you do 2 sine x minus 1. Yeah, that's exactly it. 2u.
yeah, me too. Sine
You
x
should have, that
plus
should be
1.
plus.
Isn't it supposed to
And
be
then it should be
No,
negative
that's
1.
fine. Yeah, that's what it should be.
Oh, yeah.
2 sine of x plus 1.
Yeah.
So it'd be 2u plus 1.
Yeah.
I don't know.
I make your fault. Like, not your fault.
This is. Oh, I get it
Because it
now.
should be 7 pi over 6 and
Down there, the 2 sine, because it's plus.
So it's going to be x, the sine of negative 1 half.
Because.
Oh, yes, thank you. Oh, I'm going, where am I looking here? Thank you.
Claire, I don't even have
So it's 7 and 11, right?
Yeah, sorry. I just spun the graph around because it was funny. I laughed at myself.
You like spun it and I went.
Is this for these ones? Was this one of the ones where you had to give a general solution?
No.
On some of them you did.
When we on the test itself, and what I was just looking for of these was a one revolution solution system.
All right, that's right.
When you're dealing with having to interpret Pythagorean identities within a solving a factored equation of trigonometric functions, that's a lot of crap to do. It's okay, we just do within one revolution, so you don't have to worry about your tachyons, okay? Yes, ladies?
Can we do number 3 from the worksheet?
Oh, yeah, I think I know. All right.
I have a question about like
Yes.
Okay, so you know,
Hold on, guys.
so this one you use like the reference angles and
Yeah.
stuff, but sometimes you just do it like one's here and one's here, like across from each other. So how do you know like which way to do it?
Well, here you're asking yourself, what angle has a sine value of -1/2. So when I'm looking at this in an equation, I can have multiple locations. So my sine value is negative in the fourth and the third quadrant. So I'm down 1, hypotenuse of 2, so that's why I'm at -30, but we know that that's the reference angle. I gotta come around to the theta side.
So it's only like opposite quadrants and then it's tangent?
Yes.
Okay.
Tangent is opposite quadrants because tangent is positive 1 and 3, negative 2 and 4. Another question that came up last hour about what do you do versus a question like this, where you're solving the equation, versus what angle has a sine of √2 over 2? Or excuse me, negative value. The difference between this and that is that you're starting with an equation and you're looking for all possible angles that have that within a specific parameter, general solution or revolution. This is like your quiz. Your quiz, or quizzes, you'd have to go, all right, sine starts at pi over 2, goes to negative pi over 2, and you place it. Sine values would be at -45 or negative pi over 4. That's how you simplify something like that versus solve an equation. Does that make sense? That's the subtle difference between the two. All right? So if the problem is just what is the angle given in both radians degrees, that's what you do. Solve an equation, determine the sine.
And on those ones you're allowed to do like reverse.
Yes, because you can have negative angle there. Here you'll never have negative angle. Yeah, Hannah. You said 3?
Yeah.
If you guys looked when you were walking around and walking in and stuff, I wrote a bunch of solutions on the windows outside. I like writing these things out on windows because it looks like it's really scary. It's kind of fun. Of all the problems of the 8 ones you guys did last night, I thought that the most complex pain in the rumpus one
7.
was 6.
Oh, I did 6.
Cool. For all honesty here, 6 out of all 8 of them, 6 was the toughest.
I used 3 pages.
What?
I still didn't get it.
6 is really mean. 6 is really mean. I'll just leave it at that. What I want you guys to see here, though, are these real subtle things that occur. For example, is that a perfect square? Is that a perfect square? Is that a subtraction symbol?
Most likely, yes.
I forgot all about that.
Yep, you and just about everybody else that's asked this question. Now, think about your Pythagorean identity that has cosecants and cotangents. The Pythagorean identity is 1 plus cotangent squared is cosecant squared. So 1 equals cosecant squared minus cotangent squared. Your answer, they want you to verify that it equals 2 cosecant squareds minus 1. So rewrite cotangent in terms of cosecant. Cosecant squared plus cosecant squared minus 1. And you're done. Yep. Wow. That's all it is.
Okay.
All right. Yes, ma'am.
This is probably like a really stupid question, but for number 8, there's no such thing. Are you allowed to do you have to have it?
Okay, 8. I don't know if you heard me, guys, when I was saying when I saw this one.
Are you supposed
You have to go right to left.
Okay, that's what I was wondering. 'cause
That's
I
fine.
I
Did you go left to right? Did you get it?
No.
I promise, Daniel. I'm sorry, Daniel. I might not have caught it by the time you guys got out of here. You got to go right to left. I honestly can't think of any possible way to go left to right on this unless you flip it and go 1 plus 1 over secant, and then get secant plus 1 over secant squared, which is 1 over cosine plus 1 over 1 over secant. And then it just starts to get really, really nasty. I mean, it works, but it's just awful. Yeah, so go the other direction, it's easy.
actually really easy.
Yeah, if you go the other direction, it's really easy. I promise you tomorrow on the test, everything's left to right. Okay? Speaking of tests, think about everything we've done without calculators. We've done what you did on the quiz, simplify, verify, solve general, solve within 1 revolution. Those are your problems. There's 12 of them. There are 12. There's 12 questions. You have 48 minutes. How many minutes per question?
4.
Keep pace. You have plenty of time. You have plenty of time.
It's so many will take a minute.
Like 8 minutes.
I'm not period for 47.
Give or take.
I mean, we usually start before the bell when
I feel like there's nothing extra. Like when I have it. No? Okay.
It's just a Friday.
It feels like a special Friday.
I'm not to dinner with
It's a Trig test Friday, so it's a special Friday.
Yay!
Then starting on Monday, we'll start graphing. Graphing, guys, graphing of trig functions is really, really simple. Very simplistic. No calculator. What's up? I don't know who wants to fight to the death. We got? Absolutely.
Wait, are we going to give reviews?
I got one. I want to go through a bunch of these first. So on number 5, I'm hoping by now you guys would have recognized these little subtle things that you can do. In this case here, you want to think that since you've got addition in the denominator, you might want to think that you can do your conjugate. But it doesn't get you anywhere. Okay? And the reason why I would say don't do the conjugate is because you're not going to be able to create a real clean value for anything. So when that happens, or if you have 4 parts within 1 fraction, go right to sines and cosines and get common denominators. So in this case, I'm going to rewrite in terms of sines and cosines with common denominator. So I have 1 over 1 plus 1 over cosine, all over sine over cosine, plus sine over 1. You okay with that? Common denominator. Common denominator up top is going to be a cosine. So this becomes cosine plus 1. Denominator also has cosine. So it's sine plus sine times cosine. Now the trick is when you see something that has a sine plus a sine times something,
the lines on the paper.
pull it out, factor it out. So down here I'm going to say that this is going to be sine times 1 plus cosine, all over cosine. GCF.
Oh, you just multiply the 2 bottom ones.
Yep.
But how do you get cosine plus 1?
What's the common denominator? Fraction on the left needs a cosine, fraction on the right does. It's cosine plus 1. Okay. Now, the numerator, the cosine plus 1 over cosine, there's nothing I can do there. So I'm going to multiply now by its reciprocal. So I start over with my cosine plus 1 over cosine, multiply by this reciprocal because I'm divided by all that, so I bring it up and flip it. Cosine over sine 1 plus cosine. Bless you.
Thank you. So much easier.
And you have 1 over sine, which is, there you are. You brought the fraction part. When you simplify that and you raise it, you can remember that. what happens here is when you simplified all this out, you probably just wrote down sine. But remember, this is a denominator. Up top is a 1. Oh, never mind that.
Oh, and I got the other one.
Don't do that. No. It's up.
Can you just give us a call for problems like this?
Yeah, do you have like a reason?
You guys have, I have,
Do you have any good recommendations from the book?
the book problems suck.
Okay,
That's why I haven't used any.
You can do the odds and the.
You can do odds and worksheet. I've got some extra problems here in a second, as well in a second. Yes, ma'am.
I'm probably gonna feel really stupid like after you
Don't.
actually show it. But how did you simplify like that numerator to this, or the denominator to like sine on the cosine?
Here,
Yeah.
right here, notice it's sine. Think of it this way. It's 4x plus 4. What do they have in common? I took a 4 out. What do these guys have in common?
Sine.
Took a sine out.
You took out the sine.
I think I found these all 6.
I distributed. These are distributed property.
Wait. So you took out the
Yeah.
sine.
So what's sine divided by sine?
1.
What's sine cosine divided by sine?
Wait, cosine divided by sine?
Sine times cosine divided by sine. I factored it out.
Okay.
That's all it was. Just factored it out. All right. What other one do you want to look at?
Ooh, 7 I finally got after a while.
And
7, you guys are
four.
going to kick yourself.
It was actually, it was really easy, which is weird.
This is a prime candidate of a conjugate. Because the numerator is a singular term, and the denominator has secant and tangent. Secant and tangent make up Pythagorean identity. 1 plus tangent squared is secant squared. So what I'm going to do is I'm going to multiply top and bottom by its conjugate, secant plus 1, or plus tangent.
Oh yeah, I feel like 7 was super easy.
And then from here, bless you,
It'll happen.
I know. What happens now is you get the denominator becomes secant squared minus tangent squared. Pythagorean identity says 1 plus tangent squared is secant squared. So 1 equals secant squared minus.
Wait, hold on. I need to write it down.
So this equals 1, and you're left with secant plus tangent. What I did on that one originally when I first started it, I tried to go in with common denominators and multiplying fractions, flipping stuff around. Then all of a sudden I stopped. I'm like, oh, I'm an idiot.
Yeah, that's what I did.
I wasn't taking my own advice with the, yeah. it's a nasty way to go, but
Wait, why is secant squared minus tangent squared?
the Pythagorean identity is 1 plus tangent squared.
Oh, okay, I got it.
I tried my best for the simplify, verify problems on your test not to be too long and not to be overly brain exploding.
Yay.
Did you make them?
Oh yeah, it's all done, run off, ready to roll.
Wait up.
Oh yeah, dude, we're ready to go. I'm ready to give it to you right now.
That's nice.
You did didn't I?
You talked about it, but I haven't.
Hey, congrats!
Oh, that's on the fence?
What?
They won. His first game back, head coach, they won yesterday.
Wait, don't hold on.
Oh,
Never mind.
heck. Gosh. I did it. I did it, Mr. Murphy.
Yay!
All
Alright, number 6.
Beautiful, I felt it.
Now, one of the things that I've recommended when you have a problem that mirrors something like this, where you have 2 terms in the numerator and 1 denominator, what would I say you should try to do?
Split it apart.
Split it
That's what I
apart.
did.
So if I split it apart, I get 2 over secant minus secant squared over secant. All right. Yes, what happens now, this happens, and I have 2 over secant minus secant. Now, look at what your answer winds up with. Yeah, Christian.
This is, I mean, I don't know if you ever need to, but just a question. So like here there's 2 things in the numerator and 1 in the denominator. If there's 2 in the denominator and 1 in the numerator can split up?
No, because that means it's got two parts. It's a, yeah. Now, notice your answer wants it in terms of sines and cosines. So what I'm going to do is rewrite secant as cosine. So I get this.
So it'll be
2 cosine minus 1 over cosine.
Wait, what do you
I use the
you
inverse.
just moved it up into the
Yep.
numerator.
And now what do I have to get?
The sign.
Jacob sees it. The common denominator.
Wait, don't
So,
do that.
that's dirty.
It is dirty. So now you have 2 cosine squared minus 1.
Cosine.
And what's cosine squared stand for?
Wait.
Sine squared.
No.
Wait, cosine squared?
Yeah, it's cosine
There's
squared.
1 minus sine squared.
There. So now you have 2.
Oh,
Distribute. And what are you left with? 1 minus 2.
I gotta admit,
I have a
I only
question.
got to the top part and then I just added a cosine because I was
And trust me, guys, if you BS your way through a problem, I know that you're BSing your way through a problem. You don't just make a bunch of dots and go, see? It's magic. Yeah, Blake.
I tried to look at how you like change the
Remember, 1 over secant is cosine, and secant is 1 over cosine. They're inverse functions of one another, so that's why I was able to flip them. Yes, ma'am.
Okay, wait. So when you did like the common denominator, like, I've probably asked this question like 17 times, but how did you get the numerator?
Once again, fraction on the left needs a cosine. So what's 2 times cosine? Times cosine.
Why does the fraction on the left need a cosine?
Does it have a cosine in the denominator? So it needs one. You get the common.
But then why doesn't the other one need it in the numerator?
Because it already had one in the denominator, because it's common denominator. What do you do here?
Yeah.
I haven't done this since like 7th grade.
Okay, I'm gonna do all.
What's common denominator?
6.
6. In order to turn the 2 into a 6, what do you multiply it by?
3.
So the top needs to be multiplied by?
3.
In order to,
Okay.
and what do you have to multiply that one by?
2.
Same idea. What do they have in common?
Cosine.
Cosine. To turn this one into a cosine, what do you have to multiply it by? Do you have to do anything there? Because it already has one number. That's all it is. It's the exact same process with 3 letters as opposed to another. It doesn't change. They're special. They're something. Color of sun. Did I read you guys that email yesterday?
No.
Oh, I should read you an email real quick.
Can you give us a clue?
No.
Is it a girl or a boy?
Yes.
They have multiple kids.
Yes.
I wish I
What else do I look at? You want to look at one of the other equation ones?
Good.
No, not got any Mike.
Let's have some sheets.
What do you got?
Everyone else,
All right, what do you got?
did anyone else just hear that child scream?
I have to make sure I didn't do it
Yeah.
right. Yeah, I did.
But we're in high school.
On the seat.
There's no little kids here.
Oh, no, I got them right. I'm at 4.
Okay, do you know the daycare? Three's in the class that I worked with.
So this one, notice, numerator has 2 parts, denominator has 1. Split it. All right. So now, this is cotangent. The other part is sine over cosine times 1 over sine, which is secant. And you're done. 1 second. Yeah, here, go put those out. Now, what I've got here are some multiple questions on basically everything we've been working on.
Really?
Same ideas as some of the stuff off the quiz.
So that covers everything?
Whenever she gets around to passing them out.
Okay, so does that cover everything that's going to be there tomorrow? All right.
Give him that.
Thank you. Thanks.
What I want to do here, once you guys all get one, I want to do a general solution problem. We've done one of those in quite some time.
I have no idea how to do those. Like, we went over it, I was like,
I don't understand how to I still like don't understand how to know whether it's like 2 pi n or like 29 pi.
Will it tell us if it's a general solution?
What's our general solution? The instruction here, it says, solve the equation for the general solution. So if I'm looking at a question like number 1, add 1, divide by the root 2.
Add 1, divide by root 2.
What angle has a cosine value?
1 over root 2.
1 over root 2. So you place it. You're talking general solution now.
45.
So 45-degree angle, positive cosine. So it's pi over 4.
1 over root 2.
Where else is cosine positive?
Wait, don't tell me.
there's one.
It's no, not that one. The other one. Cosine's actually that's positive.
So your two answers are at pi over 4 and 7 pi over 4. Are these two values equidistant from one another?
No.
So you tack on a 2 pi n.
Wait, but
Wait, if they are equal distance, it's just pi n? Or nothing?
It'll be pi. Yes, ma'am.
okay, I know Catherine might just said it to me, but I really don't understand what she just said. Why can't I be in the second quadrant?
Because it's not positive there.
Yeah, because cosine is.
What have we been talking about all for the past month as far as ordered pairs? Where are your ordered pairs positive? Where are your ordered pairs negative? Where's x and y positive or negative? That's what cosine and sine are. Cosine is x, sine is y. It follows that pattern. We've been saying this for about a month. What's up?
So how many can you have like general solutions or like 1 or like 2? Like can you have 4 general
Yeah.
solutions?
Well, you can have 4 general, or usually you're not going to have 4 general solutions. If you have a repeating out one where you have all 4 angles, depending upon where the angles are placed. If the angles are placed at 45 and you have all 4 of them, it's a pi over 2,
So then you
That's
just
the
pick 1
old-
and do pi over 2?
the first one. If they are across one another, if they're at pi over 3 or at pi over 6, and it's all 4 of those reference angles, then you have pi over 6 plus pi n, and then 5 pi over 6 plus pi n. Because they're rectangles, and the diagonals are equidistant. We spin around. The only time, now guys, listen to this carefully. The only time it's pi over 2n is if you have all 4 angles at pi over 4. It's the only time. Right. It's the only time that happens. Everything else is either going to be plus 2 pi n, or, like I said, if it's diagonal across, then it'll be a pi. What's up?
for number 2, would it be pi over 2 plus 2 pi n?
What number 2 are you looking at?
7 secant, and that's not 7.
Oh, okay. When you go to that one, 7 secant. So what angle has a secant value of 1? Okay.
I said 90.
What is, secant is the inverse of what? Cosine is x over r. So secant is r over x. Well, where is cosine 1? So it's at 0, then you're looking for a general solution. What do you add to that? 0 plus 2 pi n.
Cosine is,
Remember, when you're solving equations, you're looking for all.
no, I know, but I was just.
Oh, yes, if you're looking at the very first number 1, if you guys look at the very first number 1, you've got the cosine inverse of negative root 2 over 2. That's an example, that's an example of what angle has. That is radians, degree measure. It's not solving an equation. This is the stuff from your quiz where you're bouncing from here to here. Cosine's negative here. Reference angle is 45 degrees, so this is at 135, 3 pi over 4. Yes, ma'am?
For like the very back page here,
Yep, those are solid equations with trigonometric IDs. What would you like to look at?
I think any of them, because it's just like a general solution.
That's just.
It is not a general solution. You see it says it has within 1 revolution for the answers.
Can you just do like any of them? Doesn't-
Pick one.
The first one. Yeah.
What do you replace it with?
Let's get rid of the cosine.
Yeah.
Can't.
It's
Wait, no,
not
we need to
square.
go to the
It's
different-
not-
Oh,
it's not-
duh.
yeah, we do.
It's silly.
Man, you guys have a lot of work ahead of you tonight. Okay. Combine like terms. I have negative 4 cosine squared x plus 4 cosine x minus 1 is 0. I don't want to have a leading term coefficient negative, so what am I going to do? Multiply everything by negative 1, take out negative 1, however you want to write it. So I'm just going to do this. You okay with that? I just changed all the signs. So, what times what's 4? We add together to get negative 4. Negative 2, negative 2, very good. So I have 4u squared minus 2u minus 2u plus 1. I'm just doing a quick u substitution so it's cleaner. Factor out your GCFs. Take out the negative 1. And lo and behold, you went up with the same solution again. So it's 2u minus 1, 2u minus 1. So 2 cosine minus cosine x, excuse me, is 0. What angle has a cosine value of 1/2? Cosine positive first quadrant, adjacent hypotenuse, pi over 3. And where else is cosine positive?
Down.
And that'll be at 5 over 3. Those are 2 answers within 1 revolution. Cool. Yeah, Chris.
Do you think there's, I understand if you can't, but do you think there's any way you could like post on the answer sheet on the website?
If I have time.
Alright.
What?
I don't know, I just quiet, so. Never mind.
She's making eye conversation.
What else we got?
Yeah, can we scroll down a little bit?
Change all the signs. Multiply everything by negative 1.
Wait, what the heck is it like? Oh, wait. Just kidding. Just kidding.
Since there's a negative 4 start, then multiply everything by the opposite person by negative 1. Change all the signs on the path. You go back to the term coefficient. It's negative 1. And then just carry it here. 4 minus 4 cosine squared, that's why it's I put it in decent.
Oh.
What else you wanna look at? Which one?
I thought I was on retroactive.
The common denominators.
Whoa, man.
Tangent times sine is sine squared over cosine. Do you have a common denominator? What's 1 minus sine squared? You shouldn't have to look at your list. You need to know this off the top of your head.
I did write down the last one, I made it in the sinus and cosine.
And then in this case here, it asks you to finish it as 1 over secant. So cosine is 1 over secant. It pushes you to go one step beyond. One step beyond! That's a song. You didn't know that? Really?
Wait, how'd you get sine squared over cosine? Oh, wait, no, right, because tangent is sine over cosine.
Whenever I write Jason, I always write adjective.
Random thoughts?
I had to say it.
But did you?
12 questions, 48 minutes.
I can do it. Okay. 5 or 6, 11.
Do you have the answers for this like right now?
Yeah, probably not. Probably not. It's just, at this point in time, it's, I mean, I wanted, for all the things that you guys have been working on, I don't want to take them out of your hands because there's so many other ones that look the same, that way you can go back and look and see what makes sense and help yourselves through.
Split it.
I'll get you next week, okay?
Okay, yeah.
Freak out.
That's why I should not take the first
I'm a jerk, but I'm not that big. I'll give you some time, let you watch the videos, get caught up, try some of this stuff, okay? Tomorrow, I'll ask you questions. Put you through. Yeah, so you can take a,
I have her flash the flashcards and she's gonna be like,